Welcome back to Geometry Classroom. Today we'll talk about angle of elevation and angle of depression. We have two main objectives. First, we define and identify the angle of elevation and angle of depression. Then we solve problems involving angles of depression and angles of elevation. This topic is very important in many fields like topography, air traffic, building bridges, architecture. So it's important to understand this topic. Good. First, angle of elevation. Angle of elevation is the angle formed by an horizontal line of sight and a new line of sight that is above the horizontal line of sight, like we have in this figure, right? So this is the angle of elevation. The angle of depression is the angle formed by an horizontal line of sight and a new horizontal, a new line of sight that is beneath the horizontal line. And this is the angle of depression, right? Now, the angle of depression and angle of elevation are congruent or the same. Why? I'll show you why. We'll go back to initial slide. Suppose we have two horizontal lines of sight and the transversal that intersect these two parallel horizontal lines. As we know, the angle of elevation, right, is the angle formed by horizontal line of sight and a line of sight that is above this horizontal line. In this case, this is the angle of elevation. The angle of depression is the angle formed by the horizontal line of sight and a new line of sight beneath the horizontal line of sight. In this case, this is the angle of depression. But as we can see, these two angles are alternate interior, right? And the alternate interior angles formed by two parallel lines cut by a transversal are always congruent. Good. Now, we have, when we deal with angle of elevation and angle of depression, we have basically two types of problems. Type 1, when the sides of the triangles are given and we need to find the angle of elevation or depression. That's the first type. The second type is find the missing side of a right triangle when the angle of depression or angle of elevation is given. Now, let's talk about, let's have a type 1 problem first. It says find the angle of depression knowing sides of the triangle. So here it says from the top of a 210 feet cliff, David observes a lighthouse that is 430 feet offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse, right? So, as we can see in this figure, this is the angle of depression. But this angle of depression is in the same time congruent to this angle, right? Let's say x, because we don't know that angle. How we find this angle? By looking at this right triangle. Yes? Now, what is given? Related to this angle is given this side, right? And this side is opposite, right? Is across the angle x. And the horizontal side, which is adjacent, right? Because it's next to the angle. Because these two sides are given, we're gonna use tangent of the angle, right? So we can write tangent of angle x would be the ratio of opposite and adjacent. Opposite is on top, so we're gonna write 210, in the bottom 430. But as we know from a previous lesson, to find the angle, right, we have to use the inverse trigonometric tangent ratio, right? So we're gonna have x equals inverse of tangent applied to the ratio of 210 and 430. So let's find x using calculator, right? So we use inverse of tangent. So we click on trig. Let refresh our screen. So we press trig because it's inverse. We click on inverse of tangent, right? Then control divide. On top is 210. In the bottom is 430. And then we hit enter. So the angle would be around 26 degrees. So x would be 26 degrees. That is how to find the angle of depression, yes, using the given sides. Now let's have a type 2 problem, right? In this case, as we can see, the angle is given and we have to find a missing side. What it says here, a pilot is looking at an airport from her plane. The angle of depression is 29 degrees. If the plane is at an altitude of 10,000 feet, approximately how far is it from the airport? In other words, we need to find this side. Good. Now, what is given? Is given the angle, right? So let's mark the angle. Now, this side, that is 10,000 feet, is the altitude, is a side that is opposite to angle 29. So we write opposite. The side that we are looking for is the longest side of the right triangle and is opposite to the right angle. That's why x would be hypotenuse. So, because opposite side and hypotenuse are given, right? We use sine of angle 29, right? So, we can write sine of 29 equals ratio of opposite to hypotenuse. So, would be 10,000 over x. Now, in order to solve this equation, let's rewrite it as a proportion, right? How? By writing sine of 29 as a fraction. So, we rewrite sine of 29 as sine of 29 over 1. Now, we know in order to solve a proportion, we use cross multiplication. Yes? So, we multiply 1 by 10,000 and x by sine of 29. So, we're going to have x times sine of 29 equals 1 times 10,000, which is the same as 10,000. Good? So, using calculator, let's find the value of x. Yeah? So, in order to solve the equation, we press menu 3, 1, and we type the equation. So, x times, we press trig, sine 29, then equals equals 10,000. 1, 2, 3. And then comma x. But I think we have to press yes. Good, and then we hit enter. So the value of x would be 20,626.7 feet. We can round up to 20,627. So x will be 20,627 feet. That's the distance from the pilot to the airport. So, that's all we have for today. Thank you for watching my lesson.